Hi, welcome to this video on our Pirate Math Equation Quest multi-step intervention for total difference change in equal groups problems. My name is Sarah Powell. I'm joining you from the University of Texas at Austin, and I'm here to walk you through this activity within this intervention called Equation Quest. As you probably know already by now, there are 5 activities in every intervention session. We have those captain cards, Equation Quest, the Buccaneer problems, ship shape sorting, and the Jolly Roger review. Right now, we're going to dig into Equation Quest, which is a really important part of our word problem intervention. Why is Equation Quest so important? Well, Equation Quest digs into the equal sign and how students interpret the equal sign. And what we have learned over the last few years is that a lot of students interpret the equal sign in an incorrect way. They interpret it as operational, like, oh, I have to do something here. Instead, students need to interpret the equal sign as relational. That is a balance between two sides of the equation. And that's where Equation Quest comes in, and that's why it's so important. So in Equation Quest, we will always be guided by a sheet that looks like this. But you will also need other things, such as these cubes. You'll also need a pencil, and many times we'll ask students to balance between two sides of the equation. We have this paper balance that students can use in Equation Quest, but if you do have a manipulative balance, you're welcome to use that as well. So as we think about Equation Quest, students are going to work through 4 big ideas. First, students are going to learn about the equal sign as that relational symbol. We just talked about it, that balance between two sides of the equation. And then as they start to learn about the equal sign as relational, they'll practice that using cubes and then drawing pictures. And then, and this is very important for our multi-step word problem intervention, and then students will work on solving equations with multiple operator symbols within them. And here's where we're going to talk about the order of the operations. So let's break down each of these 4 big ideas. First, let's talk about the equal sign as a relational symbol. So here is the equal sign. And on every material for Equation Quest, it will always say that the equal sign means the same as. And that's what we want students to do, interpret the equal sign as meaning the same, that this side of the equation is the same as that side of the equation. So if we look at these 2 examples here, for example, 5 plus 8 equals 13, I could say it like that, 5 plus 8 equals 13, or I could read this as 5 plus 8 is the same as 13. That's what we encourage students to do in Equation Quest. If we look at this example here, 5 equals 2 plus 3, a better way to read that would be 5 is the same as 2 plus 3. That is the same as language helps us think that this side of an equation is the same as that side. And this is really important for understanding mathematics in general, but it's going to be really important in Pirate Math Equation Quest as we use different types of equations like these to help represent word problems, and then students solve those equations. So a big idea is that this equal sign means the same as, and then we can read equations using that same as language. Now, the second thing we do after students have that initial understanding of the equal sign as same as, we're going to do a lot of different activities to help them balance two sides of the equation. And one of the really nice ways to do this is by using cubes and a mat like this. So I'm going to show you how we would help students think about using these cubes to solve addition, subtraction, multiplication, and division equations. And for me to do that, I'm going to move over to my document camera. So I'll join you in just a second. All right, let's talk about how we can use cubes like these cubes here to help students understand how to solve for an unknown in addition, subtraction, multiplication, and division equations. I hand drew, which is why it's a little not perfectly sized, but I hand drew a balance mat here where I'm going to put cubes on this side of the mat and make sure that they are the same as the cubes on that side of the mat. So let's first focus on this addition equation here. Blank plus 3 is the same as 9. On this side of the equal sign, I know that I have 3. So I'm going to go ahead and choose 3 cubes right there, and I'm going to use the same colored cubes so it's really obvious that that's a set of 3. But then on this set of the mat, I have 9. So I'm going to go ahead and show 9 over here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, right now, these two sides of this mat are not the same. 3 is not the same as 9. So now I need to figure out how many I add to this side so that these two sides are the same. So let's see, if I add 1, 2, 3, 4, 5, 6, 3 plus 6 is the same as 9. I have 9 on this side and 9 on that side, so I could go ahead and write 6 in my blank space just like that. 6 plus 3 is the same as 9. I'm going to go ahead and clear my cubes, and now let's look at this subtraction equation. On this side, I have 12. I'm going to go ahead and put 12 cubes in there. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then on that side of the mat, I have 8. Go ahead and put 8 in here. Now this is an interesting one. 12 is not the same as 8. So here, because I'm subtracting, I have to figure out how many cubes on this side of the mat I'm going to subtract so that the sides of the mat are the same. So let's see, if I take away 1, 2, 3, 4, 8 is the same as 8. So I had to subtract 4 here, so that means 12 minus 4 is the same as 8. It helps me balance those two sides of the equation. Now let's get to some multiplication. Here I have blank times 3 is the same as 9. So I know that I'm going to at least have one group of 3. I'll go ahead and put 3 right there. And that's going to be the same as 9. I'll go ahead and show 9 on this side. 5, 6, 7, 8, 9. Now I need to figure out how many groups of 3 I would have to equal 9. Well, I have one group of 3. If I bring in a second group of 3, well, that gives me 6. And if I bring in a third group of 3, that helps me have 9. So now 9 is the same as 9. So I can see that I have 3 groups of 3, which is the same as 9. And then finally, for this division equation here, I have 15. Oh, let's go ahead and get out 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Always nervous when I have to get all these cubes out in front of some people. There we go. All right, 15. And then on the other side of the mat, I have 5. Go ahead, and that's much easier to show, 5. Now I have to take these 15 and put them into groups so that then there's 5 in each group. So let me think about how I could do this. I like to think about this as equally sharing there. All right, I'm going to put cubes in 3 different groups, looks like. All right, so if I want to have 5 on this side, and I want to take those 15 and equally share them among groups, that means there's going to be 5 in each of these groups, and I have 3 separate groups. So when I have 15 and I divide them into groups of 3, 15 divided by 3 equals 5. Now this one here, this 15 equals 5, that's a little bit of a complicated visual for students. So here what I would do is I would remove those other 2 groups to show that in each group I have the same as 5. So the 2 sides of the equation now balance. I'm going to go ahead and remove those cubes. I've solved all my equations, so let's go back to the slides. Here's a student work example here. You can see some of the equations that the student was working on that day. And then here's that mat, that balance mat, and there are some examples with the cubes. So once students worked a lot with the cubes to help them think about the equal sign as a balance between 2 sides of the equation, then in Equation Quest, we ask students to draw pictures. And so here are some examples for each of our operations. And we have the balance mat, and here we can just draw pictures into our balance mat. But in order for me to do that, guess what? I got to grab a marker here. All right, so here we've got this example, this addition example. Blank is the same as 6 plus 5. So over here on this side, I could draw 6 of something. Maybe I just draw 6 circles, just like that. And then I also have 5 of something. I often like to draw little X's, like X's and O's, because I love math so much, right? But if I have 11 on this side, then how many do I have to have on that side? Well, what could students do? Maybe I just draw 11 tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There, I can see that 11 is the same as 11. So what do I do with that knowledge? Let's go ahead and put it into our equation right here. I'll go ahead and write 11 just like that. So that's an example of how we could solve these addition equations with just drawing some pictures. Let me go ahead and show you a subtraction example. Now let's look at this equation, 15 minus blank equals 8. Here on this side of the equation, I have 15. I'm going to go ahead and draw 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, I kind of moved outside of my box, but that's okay. And that's actually not a box, it's a rectangle, so that's how I should have referred to it. And then over here on this side, I have 8. I'll go ahead and draw 8 circles. 1, 2, 3, 4, 5, 6, 7, 8. Right now I look at this. 15 is not the same as 8. So if I want to subtract from this side to make sure that now we have 8 over on that side, well, how many could I subtract? Well, let's see. If I have 15, 14, 13, 12, 11, 10, 9, 8, if I subtract 1, 2, 3, 4, 5, 6, 7, I could go ahead and put that on my blank space right here. If I subtract 7, then 15 minus 7 is the same as 8. Let's now look at a multiplication example. For this multiplication example, something that is helpful to do here is to use our equal groups equation as we try to think about the solving of this equation. And remember, our equal groups equation is our groups, right, times the number in each group equals the product. Try to match that as well as I can. That's going to be my best effort for today. So we know the groups. We know we have 3 groups. Maybe here on my balance mat, I'm going to show 3 groups. 1, 2, 3. And then over here, I know I have 18. I could draw those 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. 3 is not the same as 18. And I want to figure out how many are going to go in each of these groups so that I have 18 on both sides of my mat. So let's see. I'm going to take 18 and equally share them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. So how many are in each of those groups? What's the number in each group? Well, we can see that we have 6 in each of our groups. So 3 times 6 is the same as 18. Let's go ahead and look at a division example. Now let's look at this division equation. 16 divided by something equals 4. Now I know over here I need to have 4. I'm going to go ahead and just draw 4 real quickly like that. And over here I have 16 of something. So I'm going to go ahead and draw 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now I want to get these so that on this side where I have 4, I also have 4 on that side. And there I want to think about, well, how many groups can I make so that I have 4 in each of those groups? So here I could say, well, here are 4. So that's one group. Here's a second group. Here's a third group. And here's a fourth group. So if I have a group of 4, that would be the same as this 4 over here. So 16 divided by 4 equals 4. So those are just some examples how we could use cubes and drawings to really help students understand this idea that whatever we have on one side of the equation, we also have on the other side. So in this version of Pirate Math Equation Quest, we're really interested in how can we support students with multi-step word problem solving. And one of the ways that we can do that is we can use an equation that represents all of the components of a word problem. Many times, that's an equation that represents multiple schemas at one time. And if we use equations like that, or like this one that you see here, one of the things that we have to do with students is not only emphasize the equal sign, that one side of the equal sign is balancing with the other side of the equal sign, but we also have to teach students about the order of the operations. In other videos for Pirate Math Equation Quest, we've started to talk about how to use parentheses to represent what happens first in a word problem, and then we have other numbers like this that tell us what happens later. And we have to help students understand that when we do have these parentheses, whatever is in the parentheses, we want to do that math first. So for this equation right here, 2 plus 1 plus 6 is the same as something. Well, first I want to figure out what 2 plus 1 is. 2 plus 1 is 3, and then I add that 3 to 6, so if I'm solving this equation here, my answer, or my sum, would be 9. Let's look at another example. 18 minus, in parentheses, 7 plus 3 is the same as blank. Well, here let's first think about what's in parentheses. 7 plus 3 is 10. I'll go ahead and write that right there. And then if I have 18 and I subtract 10, 18 minus 10 is 8. So I kind of wrote it on the line. I gave it my best try there. So if I solved this equation, first I focused on what was in parentheses, and then I solved the equation left to right. Let's look at another example. So here we have 9 times 9 plus 26 is the same as something. Well, I have these numbers in parentheses. Here I have 9 times 9, and 9 times 9 is 81. And then I add 81 to 26. Now, some students might be able to do mental math here. That would be great. But some students may need to write this. So if I just over here to the side have to write what happens when I add 81 plus 26. Maybe I use partial sums. Maybe I use a more traditional algorithm. Either way, I want to figure out that the answer here is 107. So I did parentheses first, and then I added and then I did the operations left to right to figure out here I have an answer of 107. We have one more example. All right, look at this. This time in parentheses, I have 3 numbers, and here I'm going to add those first. So I can do this in a number of different ways, but first maybe I think about what happens when I have 4 plus 32. That's 36. And then maybe I add that to 8. I'll kind of draw that here, all right? And 36 plus 8 would be 44. All right, so I figured out what's in parentheses. I may even want to circle it there so I remember that. And now I've got 96 minus 44. Now I could do some mental math there. Often I'm going to write this here just to double check my work. And I could use different strategies here, like adding up or partial differences. I'm going to use the traditional algorithm. That's going to be the easiest thing for me today. But when I figure out the difference here of 96 and 44, it is 52. So these are just some examples where we ask students to think about setting up these equations that are a little bit atypical for a lot of grade 4 students. But if we talk about the order of the operations, and if we talk about that equal sign means the same as, this side is the same as that side, it makes solving these equations much easier. Here you can see a student work example where students are solving equations just like the ones we looked at. And if they want to use cubes, they can, or if they want to use drawings, that's fine. But also if they just want to use the abstract form of math, they're welcome to do that as well. Now we're going to check out a video of one of our tutors doing Equation Quest.
All right, we're doing Equation Quest now. So tell me, what does the equal sign mean?
The same as.
The same as. And whenever we have an equal sign, what are we trying to do?
Balance both sides of the equation.
That's right. In parentheses come what?
First in the order of.
Exactly, Rosie. All right, let's look at problem A. Can you read problem A for me?
8 times 2 is the same as blank.
8 times 2 is the same as blank, which means, can you write our equal groups equation on top? Let's write GR. Nice. So how many groups do we have?
We have 8.
And how many are in each group?
2.
Awesome. So we're going to need to make 8 groups with 2 in each group. So let's go ahead and do that. There's 1 group, 2 groups, keep going. 3. And 8. Nice. All right, let's count them up. We have 8 groups with 2 in each group. So what's our product? How many do we have altogether? Nice, and to double check our work, we can put our first finger on 8, our second finger on 2, and see where they line up. What'd you get?
16.
Beautiful. So 8 times 2 is the same as
60.
Good. Go ahead and write that for me and read it to me one more time. Read it for me,
8
babe.
times 2 is the same as 16.
Very very good, aren't you?
Thank you so much for joining this video on Equation Quest. Please make sure you check out all of our other videos about Pirate Math Equation Quest in its multi-step word problem intervention version. We do want to thank the Institute of Education Sciences who funded this work, and then we also want to thank the University of Texas at Austin and the Meadows Center for Preventing Educational Risk. They allow us to do this research on a daily basis. Thank you so much, and we'll see you in another video soon.